Hey Chargers, now we're going to look back at literal equations again today. We're going to do some more practice with them. The beginning, the first fill in the blanks that you have are all things that we talked about yesterday. So you can go ahead and fill those in. I do want to start with the last fill in the blank in the top box. It says dividing by a fraction is the same as multiplying by the reciprocal is what we're going to put in there. And just in case you don't remember, for the reciprocal, if we have the fraction 2/3, to find the reciprocal, you simply flip it over. What was in the denominator now moves up to the numerator, and what was in the numerator flips down to the denominator, so that becomes 3/2. And when you do that, if you multiply by the reciprocal, 2 times 3 is 6, 3 times 2 is 6, 6/6 is 1. And that will work with any fraction that you do. When you multiply by the reciprocal, you'll always get a 1. So when you're trying to get rid of a fraction that's in front of the variable that you're solving for, you can simply flip the fraction, multiply it by the reciprocal. So the next part is going back over our steps again. So step 1 is locate the variable that you're looking to solve in your equation. Mark it some way, highlight it, put a line underneath it, box it in, do something so you don't lose track of which variable you're trying to solve for. Step 2, you're going to reverse the operations. So whatever's happening, you're going to do it backwards to undo everything that's been done. So we're going to reverse the operations on this variable, and we're going to, in the order in which they are applied. That way you're getting rid of everything that's on the same side of the equal sign as the variable. And then step 3 is you're going to use inverse operations. So remember, inverse operations, that's the opposite, to undo all of these operations and ultimately isolate the variable that we are solving for, which is our goal. That's what we want to end up doing, is to isolate that variable. So now let's look at our first example. This is very similar to the ones that we were working on yesterday. In this case, it says that we are solving for s. So I'm going to mark my s. That's my variable that I'm solving for. And I'm going to use my inverse operations. I'm going to get rid of everything that's over there with the s. In this case, the only thing we have is a 4. So I'm going to divide by 4. And whatever I do to one side, I have to do to the other side. So I'm going to do that to both sides. And then I have this fraction p/4. I cannot reduce that fraction anymore. That's all I can do with that. So I'm going to leave it as p/4 is equal to s, because on this side we have 4 divided by 4, which is 1. So we're left with just 1 s on the right side. And that's all we can do. There's no other way that we can simplify that further or reduce that fraction. Now I want you to take a moment, pause the video, and the next example over on your paper on the right is a you try problem. So I want you to take a moment and try c is equal to pi/d. So here is the answer for the you try problem. We had c is equal to pi times d. We were solving for d, so I highlighted that. And I simply had to get rid of the pi that's on the right side of the equation. Since it's multiplication right now, pi times d, to get rid of that, I divide by pi on both sides, and we end up with c divided by pi is equal to d. Now let's go on and look at example 2. So example 2 has a fraction in it. We have p is equal to k times t divided by v. We're solving for our variable k, so I'm going to mark the k so I remember which variable I'm solving for. Now on this one, we're going to work it one way, but then we're going to talk about what happened while we were working it. So the first thing I'm going to do is I'm just going to go ahead and get rid of this v that's down here. I'm going to use my inverse operations. Since right now we're dividing by v, the opposite of dividing is to multiply. So if I multiply that by v, that's going to get rid of the v because these are inverse operations. Divide by v, multiply by v, they cancel each other out. So that's going to leave us with just k times t on the right side of the equal sign. But whatever you do to one side, you have to do to the other side. So I'm also going to multiply the left side times v, and that's going to give us p times v on that side. So now I'm still solving for k. Can't forget what variable I want to end up with over there. So now I'm going to get rid of that t. So I'm going to divide by t. Since that is k times t, I can divide by t to do the inverse. That's the opposite of multiplication. And that leaves us with p times v divided by t equal to k. Now, let's talk about what happened here, okay? If we look back up at that original problem, we have k times t over v. Now, I can actually rewrite this to where k is not actually in this fraction here. This would be the same thing as k times t over v. Okay, so these are equivalent to each other. These are the same thing. Notice how we are trying to get rid of a fraction here. We're trying to get rid of the t times v, or the t over v. So this is where that reciprocal thing can play in for us, because we can multiply this entire thing by v over t, and that will cancel out those fractions. When you multiply by the reciprocal, that ends up being k times 1, which is just k. And when you do that, you'll end up with the same thing that we ended up with in our original answer. We have v on top and t on the bottom. V is up in the numerator with the p, t is in the denominator underneath both of those. Okay, so that's another way that you can look at it. You basically did that here. You just broke it up into two separate steps. We multiplied by v and then divided by t. That's the exact same thing that's happening right here. Multiplying times v, dividing by t. We just combined it into one step over here on the right, instead of having it done out in two separate steps on the left. Either way works. We got the same answer both ways, so it does not matter. Whichever one you are more comfortable with, go for it. Okay, now let's look at example 3. This is p is equal to 2 times parentheses L plus W, close parentheses. Now for this problem here, this is actually your perimeter formula. When you are finding the perimeter of a rectangle, you are going to add up 2 of your lengths, the 2 lengths that you have, plus the 2 widths that you have. So this is our perimeter formula. Now there's a couple ways that you can work this. You could distribute that 2 into the parentheses, but that's going to give you a couple extra steps. So we're not going to do that on this one. We are going to start by marking our variable. We are solving for the w. And seeing as this whole thing is being multiplied by 2, I can divide by 2, and that will just get rid of the 2 over here. Okay, so if I divide one side by 2, I have to divide the other side by 2. And that gives us p divided by 2 is equal to, when I do this 2 divided by 2 over here, that gives me 1. So I'm left with just my L plus W. 1 times L plus W is just L plus W. So now I'm still solving for my W, so now I need to get rid of my L that's on that same side with the W. Since we have an addition problem over here, we're taking a positive L and adding W to that. To get rid of that L, I'm going to subtract it. So that means I'm going to subtract L from this side as well. And when we do that, what's going to happen is we can't combine these because we don't have the same variable. Okay, they are not like terms. So we're just going to write it out as is. P over 2 minus L is equal to W. And now this is one that if you think about it, you can use a little common sense to check your work. Okay, when you are finding the perimeter of a rectangle, you add up the length plus the length plus the width plus the width. Okay, if you take, and this step right here, what we did, if you divide the perimeter in half, you're only taking the side lengths of 2 of these sides instead of all 4 sides. So you would just be adding up a length and a width. Instead of adding up all 4 sides, you're only adding 2 sides because we're dividing that perimeter by 2. Okay, so that's where that comes from. That's some of these problems, especially the formulas that you already know and that you're comfortable with, you can kind of think them through a little bit to see how that makes sense, how it works. Okay, now take a moment and try the next example, the you try problem, a plus b plus c is equal to 180. Try solving that one for b.